Let's solve a more involved trig equation. We have sine of 2x plus the cosine of x equal to 0, and we want to solve that on the interval from 0 to 2 pi. Right, the first thing you want to do here is substitute in our double angle formula for the sine of 2x. We know this to be equal to 2 times the sine of x times the cosine of x, plus cosine that was there before, cosine of x, that is equal to 0. Now we have a common factor, the cosine of x. We'll factor that cosine x out in front and multiply by what remains. From this we have 2 sine of x plus 1, and that product is equal to 0. So we can now break this into two further trig equations where we have the cosine of x equaling 0, and we also have 2 sine of x plus 1 equaling 0. All right, let's look at the first equation. The cosine of x is equal to 0. We know that this occurs when x is equal to 2 pi halves, and also when x is equal to 3 pi halves. As before, we have to address the periodicity of the cosine, knowing that that is 2 pi radians. We'll add in a 2 pi n here and a 2 pi n in there as well. We'll come back to that here in a moment. Now let's address our second equation. We have the sine of x is equal to a negative 1/2. Once we've isolated the sign, we're ready to go. Note that the sign here is negative. And when the sign is negative, we know that we have solutions that exist in quadrant 4 and also in quadrant 3. And the Q stands for quadrant there, and we'll analyze those separately. If you take the inverse sine of both sides to isolate x, we have x is equal to the inverse sine of a negative 1/2. Piling that into your calculator, we'll come up with a value of x is equal to 11 pi 6. It might show up as a negative pi 6 depending on your calculator. And again, addressing the periodicity plus 2 pi n. In quadrant 3, we have the equation x, the solution rather, of x equals 7 pi 6 plus, once again, the periodicity being addressed, plus the 2 pi n. So those are the infinite number of solutions to this equation. Now we have to address the fact that we want our solutions to be between 0 and 2 pi. 0 inclusive, but not 2 pi. All right, note, we start with n equals 0 here on the left, the first two infinite solutions. And from that, we obtain x is equal to pi halves from the first equation. Note that if we put in n equals 1, that's going to be pi halves plus 2 pi. That's outside of our interval. In a similar fashion, plugging in n equals 0 to our second solution here, we're going to end up with 3 pi halves. And as before, when n equals 1, this is outside of our interval. So from the cosine of x equals 0, we have the two solutions, pi halves and 3 pi halves. Over here with the sine equation, let's go ahead and solve. Again, when n equals 0, what happens here? Well, one of our solutions will be 11 pi 6. If we add a 1 in there, that again takes us out of the interval. So that's our only solution for that particular part of our problem. And then again, if we plug in a n equals 0 here, it's kind of hard to tell, but that is 7 pi 6. So that is our second solution. Again, when n equals 1, adding 2 pi to 7 pi 6 takes us out of the interval. So we've done it. Now we have our 4 solutions for this equation that lie between 0 and 2 pi radians, and now we're finished. The sine of 2x plus the cosine of x equaling 0 has the 4 solutions you see in red.